Cool. So we're going to talk about mixed model arts today, the convergence of data modeling across applications, analytics, and machine learning. So who's heard of data modeling to kind of get an idea of the audience? Okay, just want to make sure I'm in the right place. Motivations for this talk. So I spent the better part of last year traveling the world talking about data modeling. I hopefully was helping resurrect the topic. The talk was data modeling is dead, long live data modeling. And the notion was, and I think still is, data modeling really feels like a lost, dying art, sort of like speaking Latin or something. But I'll get into motivations for a bit. But it seems like a lot of the follies that I'd seen personally when working with companies, either through my consulting or advising companies, had to do with data issues, often relating to very poor or non-existent data models under the hood. So this talk resonated around the world, and so I decided to pursue the idea a bit further in the form of a book, which I'll talk more about in a bit. But why now, right? Why talk about data modeling in, 2024, almost 2025? It's been around for a while. This is I think the motivation from last year. First is AI. So who's heard of AI at this point? Whose companies want to do AI? Nobody? You're kind of reluctant about it? Okay, fine. I'll assume that you're all doing it. Well, a lot of companies around in other places, they want to do AI. But one of the big stumbling blocks is the underlying data sets for to make AI a reality, especially when talking about sitting large language models, even classical machine learning models on top of corporate data sets. It's very, very difficult. I'll leave you to guess the punchline in that the underlying data is usually a mess. The data models are usually a disaster, and you sort of get what you get, right? And finally, the big question is, there's a lot of attention, a lot of money, and a lot of people working on this next generation, no pun intended, of AI. So with all the money, budgets, time, and attention focused on this topic, if we're not going to focus on it now and take it seriously and take data seriously, when are we going to do it? I mean, not a day goes by I don't look on LinkedIn or read some blog posts about how we need to get our data house in order, right? We need to govern the data and make it useful for the business and get more value from our data. Who hears these discussions or sees these discussions? Yeah, right. I would wager that we're no closer now than we were in the decades I've been in the industry. In fact, I think we're actually worse off, which we'll get into in a bit. And so again, with all the attention on AI and data, if we're not going to take it seriously now, I don't really have hope that it's going to get better with time. Maybe you do. I don't know. So a lot of companies, they're still trying to solve data problems with, quote, AI. Who recognizes this image, by the way? Hipster, what is it? Metropolis, yeah. Fritz Lang's Metropolis. It was I think one of the first modern, quote, black and white movies. And it was also one of the first movies the first movie that talked about sort of artificial beings running a business. In this case, it was a robot that would run factories during the industrial age. And this is sort of the vision that I think a lot of companies have when they think of AI, is that you're going to have this magnificent machine that's going to just magically run your business. Unfortunately, if it's powered by the existing data sets I see in most companies, that won't be happening for a while. So in the meantime, since I gave this talk, did data get magically fixed? Absolutely not. We're still talking about the same stuff, still dealing with the same problems. As I'm often fond of saying, most companies are still barely doing BI, let alone AI. And here we are. Will data get magically fixed next year? I don't think so either. So let's keep using this slide next year. And 100 years from now. So, but also why now, right? Why fixate on this mixed model arts discussion, which we'll talk more about in a bit. It's interesting. As I started this book I'm working on data modeling, in talking to data modeling practitioners, I noticed there was, the discussions are mainly on tabular data sets, structured data sets, right? But when you use something like ChatGPT or Midjourney or sort of these next generation models, it's like, do you feel like that has anything to do at all with tabular data? Of course not. They're not the same thing. It's apples and oranges or kiwis and what's another fruit from your country? Right, but we're still fixated on tabular data modeling, structured data. If I talk to analysts, right, the old trope is, we'll just use Kimball, we'll just use Data Vault, we'll use relational if we're doing applications and so forth. And really, it misses the entire point that the world's evolved past tabular data sets and it did it a while ago. So we're still fighting like World War I mentally, where the world's very much moved on. Data is growing faster than ever. I think right now, what's the expectation that I think 90+% of the data on the internet the next couple of years is going to be AI generated. So you're going to get this feedback loop, which is kind of insane. What that means, I don't know. I might just leave the internet if that keeps happening. It's a different story. But increasingly, we're talking about multimodal data sets. Again, not just tabular data, not just semi-structured, but the incorporation of text, images alongside tabular data and other use cases, right? So I think we need to open our minds to the fact we don't just live in rows and columns anymore. AI interest and adoption is real. There's not a company that I haven't talked to that doesn't have some sort of AI story. Most of them are stories. But there's a willingness to at least explore. Again, data is the key to making this all work, but data is a mess. And I think the crux is we need a new way of thinking about data as an industry. Again, I feel like we're held back by a lot of the dogmatism and practices of the past. So we'll get into it. I'm a big fight fan. I grew up in the 1980s watching really trashy films like Karate Kid and watching pro wrestling, and grew up watching Mike Tyson. And I think, the question that we always had as kids was who would win in a fight? Would Mike Tyson and Bruce Lee, if they fought, like who would win, right? And how would they win? And so you always have these like interesting counterfactual arguments. Would Hulk Hogan beat Mike Tyson? Come to find out, Mike Tyson would kill him. So these are the conversations we're having. But it was an age where, from like basically up into the 90s, combat sports was about one dimension, about one fighting style to rule them all, right? You always hear about like some Shaolin monk in some cave who had just this martial art where if you ever unveiled it, it would just be the most deadly thing in the world. And data modeling feels a lot like this. When you talk to data modeling practitioners, it feels very cultish, where there's this one data modeling style that is far superior to all others. And obviously, if you don't use this style, you just lose. And I started diving into these styles. I think this argument is complete rubbish. And this is part of the thinking that holds the industry back. We live in an age now where I think modeling is very similar to mixed martial arts. Right, so I always quip that if I hadn't gone into data, I probably would have actually been doing this. In all actuality, I actually, it's close. But probably would have been more fun, actually. In mixed martial arts, really, it's about learning an array of approaches and techniques where you can operate in any situation, right? You can fight standing up, you can fight in the clinch. If it comes to the ground, you got an array of tools, submissions, strikes, whatever. This is very much the world that we live in right now with data. It's not just about one data set, one approach, one style. Increasingly, it's going to be about adopting multiple styles to fit your situation. Sorry about the gore there. Somebody's like, I'm a bit squeamish. I do apologize, but whatever. There's a flesh wound. So we'll go over a couple things here. What's a data model? What went wrong? What's happening? And we'll get into mixed martial arts. So what's a data model? I got about a minute here. Anyone want to take a gander at what they think a data model is? Awesome. Sure, yeah, I like that. Approach to represent reality, second best approach? Okay. It's kind of like describing Python as the second best language, which is usually how I've heard it described. Anyway, here's a couple, right? So this is from William Kent's Data and Reality. It's a book that was written in 1978 that I think was really one of the first expositions on modeling data at a conceptual level. He writes data models are techniques for representing information and are at the same time sufficiently structured and simplistic as to fit well into computer technology. So at this time, the discussions are really about how do we fit data into a computer so it represents what we're trying to represent, right? Still a new concept. And I would say it's still a topic, and his description still fits where we are right now. I think people still struggle with this. It's from Steve Hoberman. Who's heard of Steve Hoberman? He's so Steve Hoberman, I consider him one of the OGs of data modeling, especially analytical data modeling. So this is, I think, his definition from 2010. But he says data modeling is a wayfinding tool for business and IT professionals, using symbols and text to precisely, that's a key word there, explain a subset of real information to improve communication. We'll read the rest. So that's great. But again, this is very business and IT focused, which is great. But I feel like these two definitions don't capture where we are now. And if you look up data modeling, there's literally hundreds or thousands of definitions. So why not have the 1,001st definition, mine? So as I looked at the future use cases of where data modeling needs to go, I describe it as a data model organizes and standardizes data in a precise structured representation to enable and guide human and machine behavior, inform decision-making, and facilitate action. So notice what this is not. This definition doesn't talk about, data modeling as tool X, Y, or Z, or approach, A, B, C, and so forth. Nor is it centered on, I guess, analytics, apps, whatever. I'm covering humans and machines. I can make a very strong argument that when we've modeled data, actually since day one, it's mainly for machine consumption, not humans, right? Because you're automating tasks. Analytics is really the only area where humans are consuming information. That's to drive insights and knowledge and so forth. But especially when talking about machine learning, again, that's not data that's fit for human consumption, unless you're capable of ingesting massive matrices of numbers. And if you are, it's pretty cool. It's a good skill. You should be up here giving a talent show. So the definition, it's agnostic to any approach, encompasses all use cases of data, and finally includes ML and AI, which I feel was lacking in all the other definitions I saw for data modeling. Okay, so what went wrong? Let's look at some of the criticisms of data modeling. It's often seen as being too slow, too costly, old and outdated. And I had one very prominent person in the data industry say that data modeling actually doesn't matter. It's not a thing, and that I was wasting my time talking about it. To which I just sort of, I don't know, I was polite. As the old saying goes, you're wrong, I'm right, and you'll eventually figure out how that works. So, but these are the criticisms, right? Who feels that data modeling is too slow? Nobody? You do? Cool. There's more honest people than you guys. But then it ends up becoming too costly. Again, these arguments, especially when I hear in the States, because I think the approach in the States is like move fast, break things, we don't have time, and so the investment in data modeling is it's a bit lacking, right? Either what the investment in the knowledge and skills or the actual practice. Old and outdated. I hear this often, where the relational data model, that's great, doesn't really apply to what we're doing now. So most people who say this actually don't understand the models they're talking about, but that's a different topic. And then finally, it doesn't matter, right? And so I can make an argument that when you touch data, you are implicitly modeling data, whether you believe it or not. understand it or not. So the doesn't matter argument sort of flies out the window in that context. I feel like the other thing that went wrong is we're stuck in the past. This is a character from Napoleon Dynamite. It's an American movie. I don't know if you watch those here. I actually ran into Jason Momoa at my hotel gym this morning. It was kind of crazy. So you have a lot of American actors filming here, I guess, or at least one of them. It's kind of super random. But yeah, data modeling is stuck in the past. This character, Uncle Rico, reminisces about the time that he almost won the state high school football championship. And this haunts him to this day. He's like 80 years old or something, and still talks about it. I think he built a time machine so we can go back in time and try and win state again. But that's sort of where I feel the data modeling industry is. We keep reaching back to the things of the past, right? Building Data Warehouse by Bill Inman that came out, 89, 90? Kimball's book, 96? Data Vault, 2000-ish? And tell me like a big mainstream approach to data modeling that's happened since then. You going?
No, I like to compare it to space. The James Webb, we've gone from punch cards and what
yeah.
At the same time, we've gone from landing on the moon to the James Webb telescope to self-landing rockets.
Yeah, exactly.
We're slow as we're headed.
Oh yeah, we're still talking about like Sputnik or something. So so it's stuck in the past. I think that the thinking in the industry needs to evolve. I mean, I see certain, like I'm not going to name names, but certain approaches to data modeling that have their conferences, and it's still very fixated on that approach and how it's the one true way. Speaking of which, one true way. So there's only one true way. Van Damme, I think it's from Bloodsport or kickboxing, but I think that was a good example of like early thinking where there's one true way to win a fight, and there's one true data modeling technique, as we talked about. And I think this is a big misnomer, and it's holding the industry back. Data is only in tables. That's another one. If you've, been on the internet, the data is not only in tables. So it takes a lot of forms. There's also this thinking that in order to do machine learning, you have to have done analytics first, right? So I think it's this assumption that, again, it's a very table-centric world, where unless you do your BI, there's no way in hell you're going to be able to do, quote, AI, except for the fact that a lot of generative AI use cases don't need tables at all. So there's that. Plus, there's a lot of use cases for machine learning. Again, where I think you can skip over analytics. So the notion I said of BI and AI earlier, it's more due to the fact that this stuff's just really hard to do, and the underlying data or lack of data models is usually the crux of it. And it's the same as it ever was, right? So there's this old number that's thrown about that 80% of data and AI projects fail. It's been 80% continuously for the past couple of decades. So I don't know. We're just really good at I think cargo culting and borrowing numbers and making shit up. The other question is, how do we add business value? Who hears this argument or this question in their teams? Cool, a couple of people. The rest of you must be adding business value. I guess it's crazy. Then of course, who feels the pressure to deliver really, really fast, often at the expense of quality? Okay, a few more hands go up. The rest of you just kind of blink twice. I'll get the idea. Right, and again, if you look at a lot of the underlying reasons, right, why projects fail, it's often data. Can't get the data, can't get the infrastructure to provide the data, data sucks, we suck, everything about it just is a bit of a disaster. So, and finally, data modeling is a lost art, which we'll talk more about. But if you talk to modern data practitioners, it's funny. I remember talking to one of my friends. She was saying, "Oh, I'm doing data modeling at my work right now." And I was like, "Oh, that's interesting. Tell me more." And she's like, "Oh, I'm making DBT models." Which is that's interesting, but that's not data modeling. That's just file convention. So it's interesting how a lot of the thinking has shifted. And finally, before I move on, we'll talk quickly about the quality paradox, where who runs in this audience? Right. So do you spend all your time sprinting really fast, or do you spend all your time maybe in running slower? Right. Most runners spend a lot of their time in zone 2, right, which is a lower heart rate. That means you can inevitably go fast because you develop more efficient heart rate. Same with quality, right? If you move slower and more intentionally, quality goes up, which means productivity goes up, which means errors go down. This paradox is somehow lost on upper management, who just want you to continue to move faster and faster, deliver a bunch of shit, and, well, you deliver a bunch of shit. That happens. But what it means is your errors compound on themselves, and it creates a feedback loop where suddenly you're doing nothing except firefighting and resolving errors. So data modeling, I think intentional data modeling done right leads to higher data quality. Who cares about data quality? Yeah, who doesn't actually? That'd be pretty cool. So what's happening? So these are 2 data engineers. They're about, I think, just fresh out of university. So these are a combination of Jira tickets and this is a data warehouse here. I think there's a dead cat stuffed under this bin. But this is the reality a lot of data practitioners face right now. I won't ask you to raise your hand if you can empathize with this, because I think you do. But the thing is, you get so used to it. Like, I swear this couple thinks this is totally normal. Like, this is just fine. But this is a state a lot of data teams find themselves in, right? You become so accustomed to fighting fires, to dealing with shitty data, that this is your workplace. If you're proud of that, cool. If you're not, see ya, stick around. So on top of this, the data landscape's getting much more complicated. Buzzwords galore, data-powered apps, AI apps, data products, data mesh, data contracts, lakehouses, open table formats, AI, co-pilots, agents, streams, all this other stuff. And more, buzzwords and things for you to do and things for you not to do and things that you wish you could do. So this is reality, right, for a lot of data practitioners. It's the things coming at you aren't getting smaller, they're growing in complexity, yet you still have to deal with the same old stuff that you had to deal with before. And applications, for example, right? I often find relational databases being used with no underlying relational data model, or really any data model. They're just a bunch of tables cobbled together. I don't even know why they chose a relational database. We'll talk about, they could use NoSQL and create a data swamp there. It's a lot more flexible, a lot easier to make mistakes, a lot easier to gloss over mistakes. But again, poor data models means poor data quality, not just for the application, but also for downstream users like you, who feels like they have to duct tape and glue together solutions to the data that you get from upstream producers. Right, all of you. Not all of you raise your hands, but I'm just generalizing. This is reality, right? I mean, the industry is in a very reactive state. Data is very much seen. A friend of mine was writing about this the other day in Slack. She feels like the data engineering is very reactive. I was like, you're absolutely right. We react to problems right now, right? But it compounds itself, and the people upstream from you also don't care about data modeling. They're just trying to clear out tickets too. So I hope you're starting to understand why data models might be important. A lack of good data modeling upstream means all of you get to be that. Analytics is interesting. So this is a survey that was done by DBT in their State of Analytics Engineering 2024 report. And some of the challenges, right? Poor data quality, data integrations, ambiguous data ownership, and so on and so forth, right? Poor data quality, you can map very closely to pretty crappy data models upstream, right? Lack of coherent data structure means that, you get to deal with the downstream and analytics. So upstream data is a mess. I find in a lot of data teams that data is either, data modeling is either forgotten about or it's like a cult. And if you try and do something outside of the cult, like say you try and introduce a different way of modeling data, you'll be shut down immediately. So it's one or the other. Either you're not doing it at all, or it's very dogmatic. I'm sure there's some areas of gray, but this is what you unanimously see around the world. Many sources of truth, right? Analytics is all over the place. This definitely compounds itself as your company gets bigger, and maybe you're writing queries for different stakeholders, and suddenly nothing makes sense. So this happens a lot. Self-service. It's a great idea. It also leads to anarchy. So especially when the underlying data model is not working, this is a bit problematic, but you see this all the time. And somebody asked, actually say when I was in London a couple weeks ago, that self-service analytics would be the death of data modeling, to which I just sort of blankly blinked and walked off. Didn't make any sense. If anything, understanding data modeling helps self-service, but we'll get to that in a bit. Here's an example of some challenges in AI. This is from a RAND survey that actually came out on August 13th this year. RAND's a big think tank, but notice some of the things here. 84% of business leaders think that AI is going to significantly impact their business. 97% of these same people urgently want to deploy AI, but 14% feel they're actually capable of doing that, which is interesting. And again, the 80% failure rate number, which just seems to crop up everywhere. A very fascinating report. If you get a chance, you should read it. It's about why AI projects fail or something like that. But it's also interesting because another reason it's cited is a lack of data engineering talent, right? We put so much emphasis on data scientists and machine learning engineers. We actually forgot about the data part. Happens. Right, so I think the challenges in AI right now, what's happening today is there's a lack of understanding how machine learning actually works. When I talk to executives, especially about AI, we just throw AI on top of it, and things will just work, right? No, not at all. Different models require different things. And some things that it requires is, I think, minimally good data. But different, even with practitioners, it's interesting. I think the go-to right now is to use large language models for everything, including classification, forecasting, and so forth, which they're not built for, right? So that's kind of the state of where we are. It's a lack of understanding of the techniques and how to apply them. Everything's conflated with AI at this point, so everything's AI. And when everything's AI, I might argue that nothing's AI. And finally, training and inference are just massively expensive unless you have a big budget for hardware or cloud compute. You're not going to be training these things anytime soon. So the future. Love the future. There's a convergence happening right now. What I'm seeing is increasingly, applications, analytics, machine learning are actually fusing together. I'm talking about who uses an app like Uber or Netflix, for example, right? I mean, it would be really weird if that was just only a Ruby on Rails app. Actually, Uber was at one point. And I think they quickly realized this isn't going to work. I mean, apps like that feed on data, right? Lots of machine learning, analytics behind the scenes, apps, but all the data feeds on each other. And this is where everything's going right now, is applications, ML, analytics use cases are increasingly fusing together. Of course, in pockets or types of businesses, this might be a bit of a lagging indicator, but this is inevitably the convergence of where things are going. It won't be enough just to be an analytics data modeler or an application-focused modeler or machine learning. Increasingly, these use cases are blending together to the point where I think probably 5-10 years, they'll be almost indistinguishable in a lot of companies. What's also interesting is this coincides with massive budget cuts, right? So you're back to potentially the days of full stack data users, which is going to require that everybody understands sort of the spectrum of data modeling approaches and when and where to use them and when to avoid them. So this requires cross-disciplinary data modeling, right, across applications, analytics, and machine learning. Who feels they have this skill set right now? You? Good? You? Yeah. But this is where it's going. You're going to be working with different types of data, right? Structured, which you're all probably familiar with, as well as semi-structured, unstructured data, so it's images, text, video, audio, metadata. Increasingly, it's a glue that holds everything together, as well as being proficient in how to use the artifacts from machine learning and AI. So this might be models, might be embeddings, it might be output metrics, logs, et cetera. And finally, graphs. Who's familiar with graphs? A few? Yeah, you're going to see a lot more of these popping up soon. Graphs are seeing a resurgence right now. Partly with the rise of large language models, graphs are shown to reduce hallucinations. So that's an interesting aspect. But you're going to start seeing them, I think, in a lot of use cases, ML or otherwise. So get familiar with graphs. Pretty cool. So how to do MMA? I think you can segment this into two buckets. I feel like two things are really lacking right now is the knowledge and practices of data modeling, and this is industry-wide, worldwide. And then I don't know that the technology is really there yet, but I'm going to provide you some suggestions and maybe how to get to it for now. So knowledge and practices. I think teams, this is software, analytics, machine learning. You have to understand what data modeling is, and I think more importantly what it isn't. And then you need to know how to do it. So invest in the training. Maybe do a book club, revisit some of the old tomes, so to speak, a lot of the old techniques. A lot of great papers. I would say, Codd's original 1970 paper on large data banks, modeling on that. The relational model for that was awesome. You should go back and read that. That was the first time the relational data model was mentioned. But start from the basics, right? Read Peter Chen's paper from 1976 on ERDs and relationship diagrams, and then go from there. There's countless classics that I think everyone should be familiar with. But that's the knowledge where you should start from first principles. Understand the underpinnings of these data modeling techniques. Why is a relational model awesome, right? You'll force you to go into areas like set theory and first order predicate logic. And you'll understand that the relational model, it's not just a way of modeling for databases, it's actually a way of thinking about data in a way that removes duplicates and side effects. That's pretty powerful. And that came out in 1970, before the relational database came out. Understand conceptual, logical, and physical data models. Who's familiar with these? Right? So, all too often what I see is we start and end with a physical data model, which is just cramming data into a data system. And then that's all you do. There's no rhyme or reason to what it represents. And so, conceptual modeling, that's really the highest level of data modeling where you're just trying to represent something, usually entities. But it's the things in your business, right? The vocabulary, the business rules, the flow of information. You're trying to model these into a way that you could potentially represent as concepts. Ultimately, they can be translated into data. But all too often, this step is sort of implicitly done, but it's not explicitly done. Logical is sort of the intermediate step where you translate the conceptual to the physical, and finally physical is where it's physically implemented and optimized in your data system. So understand how all this works, right? Know the various approaches, again, when to use them and when to avoid them. And I'd say, finally, be vigilant about data modeling. It's a practice that I wish more practitioners would adopt. It's easy to get out of the habit, but it all starts with you. And it needs to become sort of muscle memory for your team. If you can, I think, be intentional about the data models you're using, intentional about how you help the people on your team model data, then consider that a win. So for applications, for example, right, I would say if you're working with a relational database, understand the relational data model. This sort of goes without saying, but it's amazing how many software engineers I talk to who probably took a short class and covered first, second, third normal forms and completely forgot about it. This happens a lot. Who's done that actually? I'm guessing a lot of people. Right. And it's easy to do. I think it's horribly taught actually. So and there's some data modeling techniques for NoSQL streaming data as well. I think this is sort of the area where it's a bit ambiguous, and especially when you're using say document stores, streams, it's really easy to shoot yourself in the foot when modeling data for this, right? Sometimes you just cram as much information as possible into a payload. Is that sufficient? What are you trying to do, right? If you need to update this information, what does that look like? How do the concepts of the relational model translate to something like JSON, for example, right? There are ways. It's one-to-one, one-to-many, many-to-many, but it's something you need to look at and understand. And finally, there's some interesting things, relics of the past I think are still relevant. UML is one, where it's more kind of an object-oriented data modeling framework, and domain-driven design is another one, right? I think if you can invest the time to learn these, you'll be much better off. Analytics. There's no shortage of ways to model data for analytics. These are some of the big ones popular today: dimensional, data vault, one big table. But there's many, many others out there with I think varied degrees of popularity or obscurity. So avoid, again, religious adherence to one true way. I find that in analytics data modeling in particular, it tends to be very cultish with respect to its approach to data modeling. And again, avoid this, both personally and on your teams. I think for analytics data, you need to learn to shift left and right, right? It's not enough just, I think, to model in isolation, but you have to understand the shifting left part means working with the producers of the data. If you discuss, make sure the data is in good shape. Make sure that the people upstream for you understand what you're trying to do and can provide you the data that you need. If increasingly, again, with that convergence I mentioned, you will increasingly need to be aware of how to model data at the application layer and how the data needs to be used in analytics. Shifting right means that if you're a data engineer, for example, make sure you're serving data that's useful for analysts, data scientists, machine learning engineers, and so forth. I've actually heard data engineers say that they don't need to care about what downstream users are doing with their data, which I found just absolutely appalling, and I think that person should be fired for saying that. I'm not kidding. Self-service, does this kill data modeling? What do you think? I sort of led the witness on this question earlier. No, it doesn't. In fact, I think it more than ever highlights the need to properly model data, because like I said, self-service without properly modeled data is just, it's pure data anarchy, which if you're into that, that's cool, but I don't think you're into that. So, and again, increasingly you're starting to see AI being used in BI and analytics. There's not a vendor in the analytics space I see that doesn't have some sort of a AI functionality in their tools right now. So increasingly that's, it's going to just be table stakes. Like, it's interesting as an aside, like I noticed that some vendors are like saying, oh, you can do AI, on your data. And I'm like, that's basically, if everyone's doing that same functionality, like having a chatbot, I mean, it's the equivalent of having a pie chart. Like, it's not a differentiating feature at this point. It just is what it is. Finally, knowledge graphs. You're going to start seeing more and more of this pop up in analytics. I think partly because of this, partly because it does provide, I think, additional context to the data that you're not currently getting with the these data modeling approaches here. So, machine learning and AI. If you're not familiar with machine learning and AI, I would say you should become familiar with how it works. Learn the classical methods first. I would say like feature engineering on tabular data sets, since that's probably the type of data you're working with. Understand what that looks like, right? Why does everything need to be a number before it's input into a machine learning training algorithm? You should find out. Learn about training, testing, and validation. Learn how inference works. And then once you're past that, I would say go learn about how large language models work. Like how does tokenization work? Why is that approach different from this? But learn the different ways of handling data for machine learning. So again, not all machine learning is created equal. I think when I talk to data people, software people, I think they have this impression that you can just throw any old data set into a machine learning algorithm, and it'll just universally work the same. That's certainly not the case. Like, for example, time series data, if you're trying to do forecasting, that's fundamentally different than if you're doing a classification or an LLM. But again, know the difference, right? But all these techniques, they're super powerful. And again, the convergence of machine learning into all of your areas of work, this is a real thing. Mark my words. Mark my words. I sound like a grandpa when I said that. It's fun. Data-centric AI. So this is a chat that we had with Andrew Ng a few weeks ago. Who knows who this guy is? Yeah, he's, I think if you were to make a Mount Rushmore of machine learning, he's on it. So very influential person in the field. But we were talking about why data engineering is essential to data-centric AI. Yeah, 5, okay. Data-centric AI is a notion that algorithms and hardware will only get you so far with training a good model. It really depends on the underlying data, plain and simple. So, and each and every one of you can make that happen. Technology, real quick. Technology, I don't think technology is sufficient today, right? The technology that we need to do mixed model arts is very siloed. Let's focus on data modeling, for example. Let's focus on apps, analytics, barely machine learning. Talking like ERDs and so forth. And as a result, the problem with the way we work now is we're always patching upstream issues like we talked about. We're not addressing the root causes of why we have data quality issues in the first place. Why does the upstream data model suck? That needs to be addressed. Conceptual models very quickly get out of sync with the physical models. Why does this happen? Well, a lot of reasons, namely because physical models, you can just tack on more and more fields, create more and more tables. And the conceptual model sort of becomes this relic that sort of floats off in the past. And I think to get to where we need to go, we'll talk more about that, but the conceptual model, we need to have a way of tying that in sync in real time with the physical models. And again, translating the conceptual model not just to tables, but I think data models across all use cases and forms of data. We have intermediate fixes. Like I said, we have ERD, UML, and so forth. I think these are still nice. I don't think they're going to get us to where we need to go. We have semantic layers as well. Who's familiar with semantic layers? Right. So it's basically write once, reuse. Maybe say SQL code as variables. Pretty handy, but I don't think it's the 100% solution. Data sharing. I think that helps us share data, but if the data sucks, it doesn't matter. And knowledge graphs. Again, this I think is you're going to see more and more of this, but the prevalence of knowledge graphs isn't where it needs to be, I think, for us to be successful with it. So what we need to automate conceptual models to changes in the underlying logical and physical models. This is yet to be done. Across different use cases, across all types of data, while keeping a human in the loop. This is where the knowledge part comes in. It's hard to have a human in the loop if you don't know what you're doing. So anyway, stay tuned on more thoughts on this, but I think this is sort of the linchpin of mixed model arts from a technology level, and this is where we need to go. So anyway, that's mixed model arts. I'm going to leave you with this quote from Bruce Lee, who I consider, I'd say it's not the grandfather of mixed martial arts. But he said, absorb what's useful, reject what's useless, and add what's specifically your own. And this is really where we need to be as an industry when it comes to data modeling and I think practices in general. So thank you. And a few more things since I have a couple minutes. Shameless plugs. Having a new course out with Andrew Ng, Coursera. So if you're interested in that, we have a 16-week specialization on data engineering. So if you want to learn that, there you go. Or go to Coursera, go find it. Practical data modeling is a Substack that I have where you can join a community, I think it's 5,000 or 6,000 people now, and talk about all things data modeling. It's pretty awesome, really great discussions there. We also have a weekly data therapy session where if you want to talk anonymously about your issues, you can show up and judgment-free, you can talk about it. It's amazing. It's so cool. We had one a couple days ago. So every 2 weeks, I hold it for, I think it's 8 or 9 a.m., pretty earlier here, for APAC. So that's you all. So, and finally, that's my Substack. You can join there to read my unhinged rants on a variety of topics on data, of course. So anyway, thank you.